In this video, I'm going to review how to do regression in JASP. Just to start with, we're going to go over kind of the basics of the regression output. Remember, with regression, this is the formula for simple regression, where we are trying to predict y based on an intercept and a slope, and the slope is multiplied times x. So we're trying to predict y based on x. We have two statistics, the intercept and the slope. Mostly in regression, you're usually trying to focus on the meaning of the first statistic, or the statistic that's beta 1. That corresponds to the slope. That's whether there's an increasing or decreasing trend. So as x increases, does y increase as well? It's very related to correlation, especially in the case of simple regression. And usually our null hypothesis is that there is no trend, or there is no increase in x with y, or in other words, that x does not predict y. And your x is your predictor variable, or your independent variable, and y is your dependent variable. You also see in JASP, the x variable corresponds to the covariate, and the y is the dependent variable. And just to kind of go back to our alternative hypothesis, a two-sided hypothesis, is that the intercept is not equal to 0. So we're trying to predict scores based on coefficients, and we can also explain the amount of variance accounted for in terms of R squared. And R squared is just the correlation squared, and and when we use the term R squared, we're talking about variance accounted for. So it's very related to correlation, but it's just the squaring of the correlation. All right, so this is our output. We are usually given, for simple regression, in a formula like this, where we have one predictor and one dependent variable. We have an intercept, which corresponds to this variable right here, beta 0. We have an unstandardized estimate. So this value right here, 1.401, is the value when x is equal to 0. In this case, we're trying to predict the number of basketball games attended based on extroversion. So when the number of basketball when extroversion is 0, the predicted number of basketball games attended is 1.401. We're given a standard error and a t and a p-value. And what this is basically telling us is, does the intercept significantly differ from 0? In this case, it does not, because our p-value is 0.171. We know that's higher than our alpha value, which is set at 0.05. So we would retain the null hypothesis that it's likely that when extroversion is 0, people aren't attending any basketball, or they're not likely attending more than 0 basketball games. But we're not often interested in the hypotheses related to the intercept. We're really interested in the hypothesis related to slope. That's where our predictor is either changing or not changing with the dependent variable. So here our unstandardized estimate is 0.05. So this is a positive estimate. So as extroversion increases, we're seeing a slight change in the number of basketball games attended. We have a standard error, and we have a t-score. And the t-score is 3.167. This standardized right here is the standardized estimate. This is the unstandardized. So what this corresponds to right here is, as 1 unit change in x corresponds to 1 unit change in y. Standardized is sort of like looking at 1 unit standardized change in x corresponds to 1 standardized unit change in y. This is also the same as the correlation, or the R value, for a correlation matrix you're going to get. That's just a little extra tidbit. Here's our t-scores for both of these estimates, and then here's our p-values. And here we see a p-value that is less than 0.05, so we can reject the null hypothesis that there is no change between extroversion and basketball games, and conclude that with the alternative hypothesis that there is a significant change, and that as extroversion increases, so does the number of basketball games attended. We can also use this formula here to predict the number of basketball games attended based on a hypothesized score of extroversion. So let's take a look at that, what that looks like. So I'm going to just use the calculator. And what would we actually be doing here? It's kind of big, so it's blocking a little bit of the screen. I'm not sure if I might be able to minimize that. There we go. Get that a little bit smaller. Okay. So what we're essentially going to do is plug these two numbers, the unstandardized estimates, into this equation and a hypothesized value of x. So let's say we wanted to say how many basketball games are attended when an extroversion score of 50 is. And so we times 50 times 0.05 plus the intercept. So that's just this formula right here. So it's 50 times 0.05, 0.055. We get a value of 2.75 plus the intercept 1.401. And we get a value of 4.15. So essentially 4.151. So essentially, when the predicted score of and the predicted number of basketball games attended based on an extroversion score of 50 is 4.15, rounded to the 100th. All right, so that is the basics of how to do prediction. Now let's look at how you actually do these analysis in JASP. So let's go ahead and pull up the JASP window. We're going to reproduce the analysis that I just created. So we're going to go to regression, and we're just going to pull down the linear regression box. Here we have a dependent variable, a covariates, and we have this optional weights. We're not going to use the weights. So we're just going to say our dependent variable is number of basketball games attended. Our predictor variable is extroversion, and we're going to just slide this over so we can look at the output, and this is our output. Now we also get some other information here. We get the correlation, and as I mentioned earlier, the R value is the same as the standardized estimate down here. The R squared, or variance accounts for, is just this correlation squared. We don't need to necessarily worry about adjusted R or RMSE. Those are some other fit statistics that we're not going to necessarily worry about for this class. We also, ANOVA and regression are very much related mathematically. So when you do regression, you also get an ANOVA. But notice how your regression p-value here is the exact same as the p-value down here for extroversion. So your regression kind of gives you the same result, or excuse me, your ANOVA gives you the same result as the regression output, except for you get a little bit more useful information in terms of the unstandardized estimate and for the intercept and the slope. So you can plug those into your regression formula. So let's say you want to get a plot from this. Well, it's pretty easy to do. You can say you can ask for some different additional information. You could ask for confidence intervals. These are confidence intervals around the unstandardized estimate. We'll take those off. We can ask for a covariance matrix. We've seen that before in the previous video. Doesn't actually look like we can get plots here. Looks like we can just ask for some descriptive statistics. So we're not going to necessarily worry about plots here. If you needed to do a plot of these two variables, you could easily come over here in the correlation matrix and just choose number of basketball games attended and what was it, extroversion, and then ask for correlation matrix plot, and there you go. And you can see the trend line is increasing. That's what we would predict based on this regression output. So pretty easy to do to get a regression output in JASP and to get a plot, a scatter plot or a correlation plot based on that. So that is the kind of summary of everything I want to tell you about regression in JASP. Make sure you ask any questions you might have in the discussion forum.